Modern industrial automation operates at a scale that assumes massive, continuous capital expenditure is the only way to maintain precision. But at the level of basic physics, a CNC machine is a kinematic linkage driven by servomotors. The mathematics of trajectory generation is a solved problem. The mechanical iron, the ball screws, linear guides, and heavy cast bases found in machines like this Colchester retains its tight tolerances for decades. The fizzle structure often outlasts its original digital brain. Despite this, mid-sized manufacturers in Rajkot or Pune operate under the belief that their capability is locked into expensive, recurring hardware upgrades. The actual structural bottleneck isn't mechanical wear, it is the proprietary closed-loop control protocol silo. Legacy manufacturers have maintained dominance for decades by controlling the interface between the software instructions and the physical actuators. Industrial hardware does not naturally die of old age. It is intentionally bottlenecked by its software. This bottleneck is enforced through a proprietary handshake, an encrypted communication loop between the CNC controller and the mechanical actuators. When an operator attempts an unauthorized electronic retrofit to modernize the machine, they break that handshake. The control software detects this anomaly and is designed to fail aggressively. The software physically halts all operations. It stops the machine to prevent the retrofit from succeeding. The system triggers a fatal alarm, such as a Fanuc PS0090 SRAM parity error. The internal memory is permanently wiped, and a multi-million rupee production asset is rendered useless. This destructive mechanism protects the manufacturer's revenue by forcing the operator back into the OEM service ecosystem. This forced failure state is a calculated mechanism to maintain a monopoly on capital expenditure and trap MSMEs in restrictive service contracts. Breaking this cycle requires a strategic shift. Founders must treat the legacy hardware as a dumb kinematic body. The control protocol can be approached as a cryptography challenge rather than a mechanical barrier. We solve this fundamental problem through direct physical hardware interception at the edge of the network, bypassing the digital locks entirely. The toolkit is clinical: multi-channel logic analyzers to read the bus, and oscilloscopes to verify clock signals. Before deployment, every response is verified on closed-loop simulation test benches using actual servomotors to ensure accuracy without risking the machine. Ending a software monopoly requires moving past software-only thinking and executing surgical physical interventions at the hardware layer. Engineering teams in Rajkot and Pune use a 48-hour validation plan to prove this concept safely. First, they target a decommissioned Fanuc or Siemens controller already slated for retirement, isolating the operational risk. They attach the logic analyzer directly to the data bus to monitor the communication lines. They then initiate a standard automated toolchain sequence to force the system to transmit its proprietary handshake. During the tool swap, the analyzer intercepts the SRAM parameter communication as it runs across the bus. The analyzer captures this hidden logic, exposing the cryptographic layer the OEM uses to hide its commands. Successfully capturing this signal proves that kinematic commands can be spoofed and mapped without triggering a memory wipe. This leads to kinematic decoupling, the moment the proprietary logic is replaced by an independent system. Engineering teams deploy a secondary open-source edgeai device to spoof these mapped inputs back to the legacy hardware. The old architecture is a closed loop. The new paradigm uses an independent edge node to issue direct commands. The mechanical iron is now separated from the legacy software brain, bypassing the system-wide protocol entirely. This total decoupling results in a perfectly smooth, mathematically precise lateral movement that is commanded purely by the edge device. This shift moves the industry's choke point away from forced hardware upgrades. This capability gives technical founders asymmetric leverage. They can now offer protocol bypass and asset rescue services directly to MSMEs. This process rescues millions of dollars in stranded capital assets that would otherwise be scrapped due to artificial software limits. Relying on closed OEM ecosystems is an unaudited business risk. Without the ability to bypass these controls, you are renting permissions rather than owning your capability. The strategic goal is total sovereignty, owning the physical hardware and the operational outcome. This is the philosophy of restorative engineering, using technology to restore physical security and extend human capability. Mastering the kinematic protocol of a lathe yields the exact precision required for bioprinting. Controlling this sub-micron movement is the bridge to manufacturing human tissue. By breaking software tollbooths, builders restore the independence of heavy iron and prove that true engineering optimization serves the operator, not the manufacturer.